Centrifugal pump, question number 3. Centrifugal pump supplies water at the rate of 400 liters per second and the pressure difference across the pump is 200 kilonewton per meter square. Outlet diameter and outlet width are 40 centimeters and 10 centimeters respectively. Blade thickness occupy 10% of the circumference. Impeller inlet diameter is half of the outlet diameter. Assume losses in casing and impeller are negligible and zero whirl at inlet. The diameter of suction and delivery pipes is equal. If the blades are radial, determine the pump power input in horsepower if overall efficiency is 80%. The impeller speed in RPM and the inlet blade angle if velocity of flow is constant. So in this question, they will give you the blade thickness occupied 10% of the circumference. So this is the value of K. You need to develop the value of K. And then they will give you the zero whirl at inlet. So mean the V whirl 1 is equal to 0. Now, in this question, they'll give you the hint that the blades are radial. So you need to draw velocity triangle based on the radial blade. So, first step, you need to draw the velocity triangle. So this is the radial blade. So you have the V1 is equal to VF1 and this is U and this is VR1, and then we don't have any VWL1 here, so the triangle will become like this. And please bear in mind that radial blade is actually focused on the outlet shape here. So the shape must be radial here, not the inlet one. So the outlet shape is radial. It's parallel with the radial, we are parallel with the radius, and then the velocity triangle will become like this. So we have the absolute velocity V2 here. So we have VF2 and it is equal to VR2. We have VWL2 which is equal to U2 here. So, and then we list all the parameters that we get from the question. We have the pressure difference, we have the flow rate, and for this question, the flow rate is in liter per second. So, means you need to convert to meter cube per second. You must know that 1 meter cube is equal to 1000 liter. So, you could do the conversion. So, we have B2 with the width of thickness. We have D diameter at outlet. This is width of blade, diameter of blade, and we have K. And then we have diameter at inlet and blade width at inlet here. And then we write down as V1 is equal to 0, then V1 is equal to VF1 to help our calculation. So first, we need to calculate the power input in horsepower if overall efficiency is 80%. So we know that overall efficiency, the equation is power out divided by power in, and we write down as 80% equal power out over power in, so PO minus PI. So power out is equal to rho GQH like this. So we already know the pressure. The pressure difference is 200 kilopascal, so we have 200 times 10 by the power of 3, and then the flow rate is 0.4, so we have power output is equal to 80 kilowatt. So this is the simple calculation to know the power output. So, and then we have the power input here. We could calculate the power input by rearranging this equation. So we have power input is power output divided by overall efficiency. So we divide it by 0.8. So we have 100 kilowatt. So, and then we need to change the value of kilowatt here to horsepower. So the conversion is we divide by 746. So we have 134 horsepower for the power input. Because sometimes in reality, the specification of pump is written in horsepower. So the second question is to calculate the impeller speed in RPM. So in previous lesson, I already said that the only equation that have RPM is U equal pi dn over 60. So from that equation, we rearrange that equation. We have n equal U2 60 over pi d2. You may also use U1 60 over pi d1 if all the parameter of D1 could help you to solve the problem. But in this question, I think the parameter in point number 2 here is quite complete. So I choose point number 2 to solve this problem. So from this equation, we need to find what is value of U2. So from the question, it gives you the idea of assumed losses in casing and impeller are negligible. So we think that it means that Euler head is equal to the manometric head in this situation. So we have manometric head equal to Euler head, and the equation of Euler head is given as 1 over G U2 whirl 2 minus U1 whirl 1, and then whirl 1 here is equal to 0. You could refer to the question. And then according to the velocity triangle at the outlet here, we could say that whirl 2 actually equal to U2. So we have now U2 and U2. So it will become U2 square here. So we could simplify that manometric head or Euler head is equal to 1 over G U2 square. Manometric head can be calculated by using delta P over rho G. So we already discussed about this in previous lesson. So we have the delta P or pressure difference across the suction and delivery pipes is around 200 kilopascal. So we need to change kilo into times 1000 here. So divide by rho G, and we have manometric head is equal to 20.39 meter of water. So, and then from the previous equation, we could say that U2 square is equal Euler head times gravity, and Euler head is equal to manometric head. We substitute the value of manometric head and gravity here, so we get around 200 meters square over second square. So we insert it, we could say that U is equal 14.14 meter per second. So we use the value of U here into this equation. We could get the value of N here is equal to 675 RPM. And the last question asking us to calculate the inlet blade angle. So if flow velocity is constant. So the impeller inlet diameter is half of the outlet diameter. So this you could get this statement from the question. So first, from the velocity triangle, we could say that tangent beta here mean the here or equal to this location. The tangent beta can beta 1 can be defined as VF1 over U1, and VF here can be calculated by using Q over K pi D1 B1. So we substitute all the value, we could get VF1 is equal 3.54 meter per second. So and then we know that the impeller inlet diameter is half of the outlet diameter. From this statement, we could say that U1 is equal omega R1, and then U2 is equal omega R2, and then we could say that R1 is equal 1 over 2 R2, depend on this statement. So, and then we could substitute the value of R here. So we could say that the U1 is equal half U2. So we have U2 is 14.14. So now U1 is equal 7.07 meter per second. So we substitute the value of U here into this equation. We could get beta 1 here is equal to 26.6 degree.